Well, now you have finally made it to the sine waves that are high enough in frequency to be heard by your ears and your computer speakers. On the previous pages, the fastest our eyes can handle using your browser to click points and collect phase was about 2 Hz. Now we will send the sine wave points you see here directly to your speakers. Remember, at any time, if these tones bother you, you can click the pale red speaker icon to turn off tone sound. Some humans can hear down to about 20 Hz, but most inexpensive speakers can handle frequencies below 100 Hz. I'm using my big red cursor to set the frequencies to 100 Hz and play the tone. Now I have to crank up the volume for most people to hear it. You may need to crank it up even more. If you listen carefully, it sounds like a low rumble of a bass. A trombone and a guitar are two instruments that can play notes with a pitch this low. Now back down the volume so I don't hurt your ears and tune to a frequency near a musical note, namely the middle C note at 233.08 Hz. Notice how as the pitch goes up, there are more cycles shown in the graph. It gets more squished. Most musical instruments can play in this pitch range. If at any time these tones irritate you, please hit the red volume off button as I've been showing you in this demo. Now we'll take the frequency up to 2 kHz. Not too many instruments can play this high, but the piccolo and the piano can get there. There are two plots of this frequency. The upper graph is better for viewing lower frequencies since it covers a longer time period. The longer graph is an expanded view of the first millisecond of the upper graph and is better for viewing higher frequencies like the one we have now. Notice we get the two full cycles within the 1 millisecond of the lower graph, which we expect since the period is 1/2 kHz or half a millisecond or 500 microseconds. Finally, I will take the frequency up to 8 kHz. Notice I need to increase the max frequency of the slider. It sounds like an annoying buzz to me. There are no musical instruments that I know of that can go that high. I'm going to stop this sound since I find it irritating. When you play this on your own, you can take it up to 10 kHz if you want. Young humans with excellent hearing can hear up to 20 kHz, but on this web page we won't go beyond 10 kHz. I will back down the max frequency of the slider since most people find tones over 2 kHz to be unpleasant. In the next segment, we will talk about the amplitude and phase sliders. Now you have seen what adjusting the frequency of the sine wave will do to the sound. Moving from lower frequencies to higher ones increases the pitch, much like moving from a tuba to a trumpet to a flute. You might have noticed in the previous segment that we changed the amplitude to change the volume. You can see this change in the equation for the pitch tone. I will turn on the tone for amplitude of 5, then increase the amplitude to 10, then go to 20. The multiplier on the equation for the sine curve increases by a factor of 2 each time, getting louder. Increasing the amplitude increases the volume, and decreasing the amplitude decreases the volume. I will turn down the volume again to the lower setting so as not to annoy you. Remember, the sine waves we create here are being sent directly to your speakers. Notice the curve is of a sine wave, but what about cosine? As you remember, cosine is the same as sine, but shifted by 90 degrees. I will change the phase to 90 degrees and note that the equation is sine of 2 pi times frequency times time plus pi over 2, which if you simplify this is just cosine of 2 pi times frequency times time. You can hear that changing the phase did not change the sound. Sine sounds the same as cosine, so changing the phase doesn't change the sound, as long as we change the phase slowly. Feel free to play around with the sine wave parameters of frequency, amplitude, and phase on your own. On the next page, we will compare these sine waves to real recordings of musicians and singers performing a few notes. I can't wait to tell you all about it.